Hi, and welcome to Backer Breaks It Down. In this episode, we continue to solve logarithmic equations. Okay, so you guys have on your summary sheet, you have a flow chart that shows the methods of solving exponential and logarithmic equations. Okay, so when it comes to these particular logarithmic equations, the unknown is inside of the logarithm. So I mean like the variable that you're solving is inside the logarithm. Okay. Now, it could be a one-sided logarithmic equation, or it could be like two-sided logarithmic equation, right? The bottom line is it's one log equals a number, or it's one log equals one log. So what if there's more than one log on one side of the equation? Okay. If that's the case, then you're going to use the product rule or the quotient rule to condense the logarithm so that there's only one log. Okay, so we use the product rule whenever we have like log plus log, we can write it as log of a product. And if we have log minus log, we can write it as log of a quotient. Okay, so we have to condense the logarithmic expression first before we can go about solving. So quickly, if you look on the right-hand side here, notice that on the left side of the equation, we have two logs. We have log base 6 of 3x plus 14 minus log base 6 of 5. So we have to start this by using our quotient rule, okay? Because we have log minus log. So I need to write that as one singular log, and I'm going to write it as a quotient, okay? So now look at what we have. We have log equals log. And so that's where we come to this step in our flow chart. What does the equation look like? And it looks like this, where we have logs on both sides. And so we're going to solve that using the one-to-one property of logarithms, which basically says that the insides are equal. So that's what they did here. Okay, the insides are equal, and then they solve for their variable. So they got x is 2, and then they check it. Because remember, the inside of the log must be positive. Okay, any log that's in the function or in the equation has to be positive when you plug that in. And so the 2 would work out. Okay, taking a look at another example here, we have log base 2 of x plus log base 2 of x minus 7 equals 3. So is there more than one log? Yes. We have log plus log, so we're going to use our product rule to condense that. And notice that that's what they did here. So they multiplied x and x minus 7 together. That's your new inside. What does the equation look like? Well, this equation has log equals a number. Okay, so we're going to use the definition of logarithm to solve it. Okay, so get the log of ln, that's done. Use the definition to convert. So here you have the definition. 2 to the third power is equal to x times x minus 7. They're solving for the variable. This is a quadratic equation, so you got to like get it equal to 0 and factor. They got two solutions here. X is 8 and x is -1. The fourth step is always to check. So here they actually gave us a very detailed look at them checking these solutions here. And they said check 8. So notice like they plugged 8 in to the insides, and you got 8 and you have 1, and that's good. 8 and 1 are both positive numbers, and positive is what we want to see when we check for extraneous solutions. With -1, so they did that. And look at, they have log base 2 of -1. That is not defined. You can't have log base anything of a negative number. The domain of a logarithmic function consists of positive numbers only. So there's only one solution here. So algebraically, like we got two solutions, but only one of them is defined for a logarithmic function. So the solution is simply 8. Okay. So let's actually try one of these from start to finish. Okay. So number 5. I have log base 9 of x plus 78 plus log base 9 of x equals log base 9 of 79. Okay. Is there more than one log? Yes, there is. I have log plus log, so I'm going to use my product rule to write this as 1 log. So on the left side here, this will become simply log base 9. And then I'm going to actually multiply those two things together. So x and x plus 78. And you can do that in this step, or you can do it in the next step. Eventually, you'll have to like distribute though. Okay. My equation looks like this, where I have log equals log. So you know what that means? It means the insides are equal. So I'm actually going to say that like x times the quantity x plus 78 is equal to 79. And this is where I'm actually going to do my multiplying. So I'm going to go x times x is x squared, and then x times 78 is 78x equals 79. Since this is a quadratic equation, I have to get it equal to 0. And then I can go about factoring it. So I know that 79 times 1 is 79. The 79 would have to be positive, and the 1 would have to be negative. So algebraically, I get two solutions here. I get x is equal to negative 79, or x is equal to 1. Since this we're talking like a logarithmic equation, I have to check for extraneous solutions. And so notice like negative 79 here just wouldn't fly, because I can't have log base anything of a negative number. So negative 79 is extraneous. It doesn't work. 1 would work. So I plug in 1 here, log base 9 of 1, that's positive. It would work here, 1 plus 78 is 79, that's positive. So x equals 1 is our solution. In problem number 6, I have log base 5 of x plus 16 minus log base 5 of x equals 1. So is there more than 1 log? Yes, there is. I have log minus log, so I'm going to use my quotient rule to condense. So here on the left side, I get log base 5 of x plus 16 over x equals 1. What does the equation look like? Well, it looks like this, where I have log equals number. So I'm going to use the definition to convert. So the base of the log is the base of my power. The log is equal to the exponent, and then I fill in the rest. Okay, this is a really simple rational equation to solve. I simply have to like multiply both sides by the denominator to get rid of it. So then I have 5 times x is equal to x plus 16. Okay, and that would give me 4x is 16, therefore x is 4. And then I just need to check and see, is 4 an extraneous solution or is it an actual solution? So if I plug in 4 here, 4 plus 16 is 20. 20 is positive, so it checks out. If I plug it in here, I get log base 5 of 4. 4 is positive, so it checks out. So x equals 4 is indeed the solution to my equation. Okay, and so that's how we solve logarithmic equations. Okay, so look to see, is there more than 1 log on one side of your equation? If there is, use the product rule or the quotient rule to condense it. And then from there, we're either using the definition or the one-to-one property to solve it. And that's how Becker breaks it down.